Good afternoon, or good morning, or good evening, depending on which part of the world you are. Thank you for this invitation. I'm really excited to be here to present out the work we have been doing in our IoT, Internet of Things group at Intel, in the space of logistics. My name is Giby Raphael. I manage a segment called Logistics and Asset Management in the IoT group at Intel. We have a portfolio of products targeting the logistics space and looking at the interface between IoT and this vast logistics market. So today I want to try to talk about not just the technologies that we work on available today, but also try to leave you with a vision of the future, if I can. So global logistics is a huge market. It is trending $8 trillion with a T today, and growing at high 20s CAGR to $10 trillion in 2020. But this market has many uniqueness about this market. If I can point out a few, from first-hand sources I've heard, and I've done a little bit of exploration myself, it seems no major global technology innovation has happened in this market for many decades. In the last mass scale innovation that happened is the barcode scanner. That happened in 1970s. So many market reports, including tech and logistics service provider company reports, say that there's at least 20%. That's about close to $2 trillion of efficiency improvement to be gained in this market. And this is one of those market which I call the engineer's dream, right? It is one of those worst case specifications and one of those stringent variables as any IoT use case can get to. For example, power. Logistics is global, logistics is mobile, and you need a technology that could work, say, from few hours in some cases to few months in some cases, especially when you're shipping through ocean and you have a customs delay, and last thing you want to do is to go invisible in the middle. Then cost. It's a highly cost-sensitive market, a little bit more than the other markets, if you may. Nobody wants to pay extra for shipping, right? It's an overhead. Profile, right? So any device, or especially in track and trace you build, cannot add weight or size to the package. It cannot. Last thing you want is to have your tracking device attract attention, right? So ideal situation is it should look like a label. So all these parameter specifications makes it really hard to build products in this space, but that's also the exciting part. However, currently, I would call that we are at an inflection point in logistics. Shipping was a commodity. It's nothing new. It's been going for decades, and shipping was a commodity. It was part of an overhead, but things have drastically changed, right? Supply chain is looked upon as a differentiation today. A company that we are all familiar with, Amazon, built their business based on supply chain optimization, right? We have constantly see, like Dough or Domino's Pizza. They all call themselves a logistics company, and not a fruits and vegetables company or a pizza company anymore, right? So logistics is a huge differentiation. So one super variable that everybody likes to optimize in logistics is delay, right? How can you get to the destination faster or the fastest way possible, right? So making faster planes or cars or trains or ships or even drones cannot by itself achieve that, because there are laws of physics that'll, you'll hit the limits there quite soon. There needs to be a myriad of technologies and standards that needs to come together in order to hit, in order to make this possible, right? So a zero delay supply chain, in my view, can only be realized with true autonomy, right? Where the supply automatically can fulfill the demand and without human in the loop. So that is the world of IoT is enabling. And I'm happy to say that Intel is in the middle of all that, right? So moving on to the next slide here. So data is the new oil. It's a common theme and a statement you've heard again and again these days. And Intel uh, is infrastructure provider, right, to this smart and connected world. We call our strategy the virtuous cycle of growth, and in a very high level, what it essentially means is more connected things drive more data, which drives accelerated cloud build out, and more insights you drive more value to the user, result things completing the virtuous cycle. So our strategy is to invest in IP that feeds this virtuous cycle, and IoT is an absolute accelerator of this virtuous cycle. So it's high up in the strategy for Intel. So I get asked this question quite a lot, like why now, right? What is this hype now? Embedded systems, the precursor to IoT, has been out there for decades. What is the hype now, right? So I like to say we are again at an inflection point in terms of technology. By 2020, there will be 50 billion devices projected to be connected to the cloud and talking to each other. That's about 6 devices per person in the world, right? So what is fueling this growth? The cost of sensors, the cost of connectivity, and cost of compute have dropped so low that we are at a point where we can now talk about connecting everything, right, in a very cost effective way. So, including the new things as well as go back and connect the old things out there. So, this inflection of ubiquitous computing, right, computing everywhere, will change the way we live and work. It's going to change the world as we see it, right? So, going back to the autonomy. So, what is the path of autonomy? Paths to autonomy, right? Connecting the unconnected is definitely the first step, and we are going through that process as we speak. We live in this era where everything is getting connected or is connected, but we very quickly run into issues such as bandwidth issues or security issues, and in some cases latency issues. By having these devices talk directly to the cloud. A classic example of that is autonomous cars. The latency of cloud making the decision is just too high for the autonomous car to operate safely. So we run into bottlenecks there. So we need these devices to be smart at the edge and even talking to each other and taking decisions quickly without relying on the cloud for everything. And thus the advent of the next stage, which is the advent of smart devices, not just connected devices. So as these devices become smarter and more self-sufficient, and as we push more capabilities to the edge, the smarter things will start talking to each other, and there's less demarcation between the edge and the cloud at that point. You have compute at the edge as well as in the cloud, and edge is as smart as the cloud, or very close as smart as the cloud, which would eventually pave, in my view, the way to true or full autonomy. Um, and that's the future we are looking at. So now switching gears back to the supply chain and logistics space. So Intel supply chain, Intel has a very fairly complex, it's a complex supply chain, and it's rated number 6 in the world according to Gartner. This is a rating that came out this year. We ship to more than 68 countries in thousands of locations, 3,000, like 10,000. We have more than about 10,000 suppliers, clear millions of invoices a year. But 30% of what we ship is high-end fab equipment. And I have no shame to say that even we have issues. You're talking about the number 6 supply chain in the world, right? We have had instances where we ship expensive fab machines that arrive out of calibration due to shock and vibration. Obviously, recalibration doesn't cost much, and we can afford that. But what we cannot afford is shutting down the fabs because of the delay, because this equipment, a machine arrived out of calibration, and we couldn't catch it at the right time. Even today, we send armed guards behind trucks when we ship our expensive server processors in some countries. So We believe that IoT will change all that. IoT will play a critical role in improving the efficiency and reducing this waste in the supply chain. So while trying to solve Intel's problems, we started looking at the world around us, right? And found very quickly realized that it was even worse than we thought, right? 30% of packages shipped last year were damaged, delayed, or lost. Many of us could, identify with that. There could be some of our own packages that came this year or last year. $60 billion of economic value was lost due to theft alone, just because of theft. An average in U.S. Two thefts, average value 200K in U.S. every single day. Right? So it's a really high number. And the third spoilage hits very close to my heart. But 30% of the world's perishables doesn't reach the fork from the farm. I grew up in India, and 65% of the perishables in India doesn't reach the fork from the farm. That's a big, big, big number. Half of the food produced in the U.S., that's more than $160 billion of food, doesn't reach a plate in the U.S. So that's massive wastage. And at that point, we're not even talking about building a technology or making money. Bringing down some of these pain points could put a dent on world hunger, could feed countries and millions of people, right? So the pain points are everywhere and mind-boggling. And at this magnitude, we are not just talking about building a cool technology, right? We talked. Well, we are talking about something beyond that. So we talked about this one axis of optimization, which is time to destination. But the problem with supply chain today is that while optimizing for time to destination, the two other axes, which is one is cost, the other is asset utilization, they're going crazy and out of bounds, right? Companies are overcorrecting for and pumping more into the system in order to optimize just on one disk parameter delay, right? So there's a new realization in supply chain that it's not just about time to destination. There's a few other things you need to consider. So end-to-end optimization is becoming key. Everybody's realizing that. But obviously, fundamentally, you cannot improve something that you don't measure. So that is where data is becoming key. A good example, I like to say this example, which resonates with us, which is strawberries, right? An average shelf life of strawberry is 14 days. And every 1 hour of out of compliance, out of 34 degrees Celsius, as soon as the strawberry is plucked from the plant, you need to chill it to 34 degrees Celsius. And every 1 hour of out of compliance reduces the shelf life by 1 day. So, there's a lot of effort trying to record shelf life and all that during transportation, but there's also a lot of time left from the farm to the chiller. It hits the chiller. There's hours and hours wasted there. There's time in the chiller, there's time in transportation, the time in the retail store. It's essentially the end-to-end, the area under the curve that counts, right? That adds up to this 14 days. I've had instances, and I'm sure you have had too, where it looks bright and sharp in the retail store, but you bring it home and the next day it's gone. It's just it's all about shelf life, right? So an end-to-end optimization, not just faster delivery time, but also cost and asset utilization is hugely important in such cases. And reefers have quite a variability in the temperature inside the truck, and so there's a variability between the strawberry sitting near the door versus what is sitting closer to the chiller, right? And depending on your luck for that day, you get the good ones or the bad ones, right? So essentially, it boils down to we need cheap data, right? So we need cheap data. We need 3D data. No, I call it the visibility cube, the past, present, and future. So you need data in real time for real time mitigation. Trend analytics is huge. You don't need machine learning to decide, hey, that route breaks my package, right? So you have data from 6 months from a route, and if your package breaks every single time, you can just common sense or basic analysis to say take a different route, right? So trend analytics plays a huge role. Then there's the holy grail, predictive analytics, right? If you can predict before something happens, then you can actually prevent it from happening, right? So that applies a lot to perishables, especially area under the curve. If you can keep a track of the area under the curve, the out of compliance data from the farm, you can do a lot of things with that data in terms of prediction. Um, and then number three, useful data, right? So the more you move away from the freight, more noise get added to the information, right? Like the human error, the paper delays, the telephone calls, the subjective assessments. If you look at the chain today, you have the information coming from the driver. Driver looks at the freight and reports information. Then there's a subcontractor in the middle. Then there's a contracted carrier in the middle. Then there's a 3PL logistics provider. Then there's a 4PL logistics provider. And by the time the information gets out, it's too noisy and detached in time, and too late for any kind of mitigation, and too noisy for trend analytics, even if you store it, and absolutely no way for predictive analytics. It's too late. So we need to have the freight talk. That's the only way. We need to get to the source. We need to have the freight talk and avoid this noise. So we need useful data. So we need cheap data, a cheap way to collect the data. We need 3D data and useful data. So I see I see a comment that says slides are frozen. I'm on the slide called industry pain points. Are you seeing the same slide, Aditya? Okay, good. So we believe that real-time visibility into the location, condition, and integrity of freight can bring down these pain points. Or in other words, we want to have the freight talk, right? A cell phone for the freight, essentially. So moving on here. So back to the question again. Supply chain pain point did not start yesterday. It was there. Supply chain has been there for decades, and all these pain points have been there forever. But why do these pain points still exist? It's 2017. Why hasn't technology solved these? Uh, um, I like to say because of three reasons, right? I like to say it's cost, cost, cost. This is a survey that Intel did some time back with relevant stakeholders on why to answer this question. And on cost, there are two aspects of cost, right? So there's a capex, capital expenditure cost. So once you put a decent compute, a memory, and a modem in a box, it's going to cost you hundreds of dollars. All right, the iPhone that's sitting next to me is a classical example of that. But you cannot put one of these on every package. You cannot make the freight talk using that, right? It's just not cost effective. It breaks one of the three things I said. It's not cheap. It gives you 3D data, perhaps. It gives you useful data, but still arguable. If you cannot put it on a freight, then tracking the conveyance is not good enough. But it's definitely not cheap, right? So you need to have all three done: cheap, useful data, and 3D data. So and in cases and unfortunately, all the issues happen at the freight level, not the conveyance level, because the freight is not always attached to conveyance. You start tracking the conveyance, right? We don't hear as many stories as trucks getting stolen as much as the packages getting people running away with the packages, right? So theft happens at the package level most of the time, and even more in industries like pharma. You need tracking at the package level, and as I said, the reefer has variability even within the truck. So a vaccine sitting near the door may have a different surrounding ambient temperature than the one sitting next to the chiller, right? So we need a cost-effective way to track at the package level and not at the conveyance level. Conveyance level is not good enough. So that's just a capex cost. Then there is also an opex part to this, right? Which is the cost of, as they call, reverse logistics, right? Shipping is one way, so you ship from source to destination, but these tracking devices cannot be one way. You cannot throw it away at the end of your journey. These are too expensive to do that. And you cannot afford to have a one-time use application for these things. So And many of these things and many of these tracking devices don't come back. And I've heard that 40% of the time across international borders, you ship across international borders, these devices don't come back. And even when they come back, you have breakage, you have inventory. Sometimes it comes back after 8 months. It gets shut out in a warehouse. And if it comes back after 8 months and you cannot predict when it'll come back, then you have to kind of maintain your inventory to address that. So it's a pain. The reverse logistics is a pain that this industry has not solved, and that is that's been a critical factor why track and trace technology hasn't scaled. So, and then you have other issues like security is very critical. Last thing you want is to advertise to the world that you're shipping a high value asset. And interoperability and standard is keeps coming again and again, right? So the companies who are going to use this or you're going to sell this, the channels who would integrate with this technology, they don't want to spend millions of dollars to integrate this and tomorrow turn around and have to see another technology come on board and now have to re-spend that money. So especially for the channel that this technology is sold through, interoperability is a very very important factor. So this is when Intel supply chain came to us in IoT a couple of years back and asked us to see if there's a solution IoT for all these problems, right? To start to begin with solving Intel's problems and then even applying this for the world around. Apologies for the background noise here. I hope it goes away soon. It's somebody doing things outside. So we ended up. So we looked at this problem and essentially created, or I like to say invented a platform ground up, which could tackle these issues. We have we call this Intel Connected Logistics Platform. We have about 20 patents on this. So I'll just go through, we don't have time to describe all, but I'll go through three critical ones. So the first thing we did is we looked at the package and looked at what we need. What's the minimum we need to track at the package level? We don't need a modem or a sophisticated compute at the package level. We need a basic data acquisition device with an MCU, a bare metal MCU with 5 sensors. So we have one SKU that has temperature, humidity, that can send shock, vibe, tilts. Then you have a light sensor that can detect if the package is open or not. And then you have proximity sensor, which I'll get to what that is. So at the package level, that's all you need. You need a cheap data acquisition device at the package level. And that's what we built. So the second problem is, hey, now that we have data at the package level, how do you get this data to the cloud, right? And we don't have a modem in it. So instead of looking at a long-range radio, we decided to put a short-range radio in it, right? So, but by definition, short-range radio has a problem, which is that it is short-range. So Intel invented our own proprietary mesh network to actually use multi-hop to compensate for the range problem. And then we have this unit called gateway. So we really look at gateway as not a tracking device, but as an infrastructure. So right off the bat, there's some construction going on outside. I apologize again for the noise. Hopefully you can hear me. So right off the bat, we have a mobile instantiation of the gateway where we can take the gateway through the gateway travels with the package. Package talks to the gateway. Gateway aggregates the data and sends it to the cloud. We also have a technology where these tags can move from one gateway to the other. So what I mean by that is, the closest analogy to that is a cell phone, right? So you have your cell phone. You can assume which is a sensor. These cell phones can move from one tower to the other seamlessly, and securely. You can internationally. So that's the vision we have. So once we have this gateway as infrastructure set up in trucks and warehouses and ships and planes, These gateway doesn't have to travel across the borders. These sensors though can travel from one gateway to the other while maintaining this end-to-end visibility. We call it the conveyor belt of gateways. It takes time to build infrastructure. So we have a mobile instantiation of the gateway. It's smaller than an iPhone that can travel with the package today, right? And provide end-to-end visibility. But very soon we see a future where you could go into a store and get a sensor tag, a little bit more expensive than the paper label you have today. That's all you pay for, and then you have end-to-end visibility from source to destination. That's the future we see. And then, so that kind of tackles the reverse logistics problem where the sensors could be cheap enough, which is throw away, but this gateway is infrastructure, which doesn't get moved around, or which doesn't have to be shipped back. Then obviously we have, as Intel, we have a lot of value prop added security, hardware-enabled security, and we are taking a key role in interoperability and standards as well. Similar to the, I call this analogy of the USB, right? So where it should be plugged in and it should work, right? So we are also we're looking into that aspects as well. So essentially, given these value props, we think we can address at least the key pain points of or the implementation challenges of the technology today. So this is our track and trace platform. By the way, this is available today to buy through Honeywell, who is our market partner, go-to-market partner. And this whole instantiation of this platform, including sensors, including gateway and the cloud, is available from Honeywell. So I think we have a little bit more time here. So I'm going to talk about one other technology we're working on, which is package dimensioning. One statistics we pulled showed that more than 50% of the time, these DIMMs, the dimensioning of the package, it's if you haven't seen it, it's still done using tape, and it's done multiple times from source to destination because the shipping rate is based on the billable weight. So the billable weight is not just billable rate is not just the weight; it also takes care of the volume. So you need to know the volume of the package in order to put a shipping rate on it. So the person who drops it as well as the person who picks it up, at least from industrial setting, measures this. And today it's measured using tapes. And just the subjectivity and human variability brings in a lot of variability to the measurements, right? So more than 50% of the time, when you remeasure, there's a variability there. So we have Intel's RealSense technology. These are depth sensing cameras that can do not just X or Y, but also Z measurements. So we have this technology where, again, from the context of taking human out of the loop, where you could do measurements of the boxes, right? It could be in different lighting conditions and different colors or different shapes of the package, irregular shapes included. We can do a measurement in 2 seconds, and which is a huge reduction in time and an improvement in efficiency and reduction in the error or variability introduced by the humans. This is another technology working on. We should be seeing this in the market quite soon with this algorithm through our partners. And again, considering that we have a little bit more time here, and just very quickly on this one slide, no talk on autonomy will be complete without at least touching on autonomous vehicles. So it's one of Intel's biggest bets. It's no secret. But 1.3 million people got killed last year due to road accidents, right? That's about 3,000 a day. 50 million, not counting injured, 50 million got injured as well, right? Autonomous vehicle can enable a world with zero accidents and mobility for all. Zero traffic is good enough for me. If we can even achieve that, that's huge. Intel is putting together the brains, the compute, as well as the vision, right, through Mobile Eye to make this a reality. So again, this is not a topic for today, so I'll just I won't stay too long on the slide. So this is my last slide, and then I can open up for questions. So where is this all going? right? So IoT is enabling a myriad of technologies, as we discussed, and more importantly, facilitating cheap, good quality, and granular data that would provide what I call the visibility cube, real-time mitigation if something happens, and monitoring, and trend analytics using data, and predictive analytics to really reduce wastage, improve visibility in the supply chain. So what you see here is the famous Pascal's experiment on fluid dynamics. Some of us would have tried this in our labs growing up, or have seen it working, right? So what it essentially is you have different sizes and shapes of containers, but you see a mechanism where the demand is automatically filled by the supply in real time in order to optimize on a single variable, which is the water level in all the containers, right? So no matter what the size of the container is, or how far away the container is away from the supply, you have the demand being filled by supply automatically, right? So why is that? So two obvious reasons. It's no rocket science here. So it's one, all these containers are connected. It's a connected container. And number two, you have one common force, which is gravity, acting on all containers equally. So it's optimized on a single variable, which is gravity. And gravitational force obviously doesn't uh, is dependent on depth and not necessarily on the shape of the container or thickness of the container. So it acts equally on all the containers. So this is the world of autonomous freight. If you consider, if you take the analogy, where everything is connected and machines are globally optimized through data analytics, through common variables, where as the supply increases, where the demand increases, the supply automatically fulfills it, no matter which part of the world you are at. So this is the world where your closet knows when you're out of shirts or shoes and orders them for you ahead of time. Or a factory with predictive maintenance knows when the parts run out and order replacement parts right on time. Or your inventory is working on prediction based on and the order quantity is always right, right? So this is the world the IoT is enabling. So that was my last slide, and I will conclude here. That was my 40 minutes here. So I'll open it up for questions, and I'm monitoring the chat window. So if you have questions, feel free to drop it on the chat window, and happy to answer them. Okay, I have one question. I'm going to read the question out loud so others can hear it as well. So I understand that your solution have been used within Intel so far. Moving forward, given the upfront investments, which industries do you think will adopt IoT solutions into their supply chain? Perishable is an obvious choice, but can you share a few others? Happy to. So the way I look at it is so in terms of attributes we enable, right? So visibility is definitely one. It pays off to know where your product is at every instant. So today's technology, if you do go to UPS or FedEx and buy tracking, you can obviously know when it hits their DCs or warehouses, but in the middle. So what technology IoT can enable you is to every instant you can tell you where your product is. So that can help every industry, right? So knowing where your product is helps you to plan and things like that, right? So that can help every industry. So, but then now when you get to condition tracking, perishable and pharma, obviously by law, right, by regulation, they are forced to track more than location, right? They need to be able to track humidity, temperature. And then you have obviously the high end, high value, right? So we looked at a study. We did a little bit of ourselves too. We looked at all the freight being transported, and we think about percent of the freight will fall under high value, right? So which could afford such a solution, or which would see an ROI with the solution. So within the 27%, I would put three buckets. So one is high-end capital goods, so the lithographic machines and which cannot be tilted, which has shock and vibration sensitivity and all that. So we need today it's using analog sensors. They use ink sensors. So you have ink in one compartment. When it leaks to the other compartment, it it tilted. But the problem with that is you don't know how many times it tilted. You don't know where it tilted. Who's responsible for that? So there goes your trend analytics. And then you need to know, you have a human in the loop, right? You're dependent on somebody to look at it and report it out. And that doesn't happen all the time. So you have no mechanism to catch it as soon as it even happens or before it hits the destination. So capital goods, obvious, it will be a great fit for this technology, and it's all of these expensive billions of dollars worth products. We can actually enable tracking with at the same price or a little bit higher with what they're using today with analog sensors. They're getting much more by paying a little bit more, right? So that's one. And then we talked about pharmaceuticals and perishables, and the other category would consumer goods, right? So actually, 2 days back, somebody stole a truckload of the brand new iPhones from San Francisco, and they amounted to $300,000. Like this happened like 2 days back in San Francisco. I read this in the news. So high-end consumer goods, obviously, so theft prevention would be a key one. So vibration uh, theft, and then the other category would be anything high value, right? Rolls aircraft engines, Rolls-Royce engines. So they have when the engine is not on a plane, not fitted on a plane when it's transported, humidity plays a key role in keeping that intact. So being able to sense that. So there are, I would say, about 27% of market can afford this technology and can use this technology, both condition tracking and location tracking and tampering detection. I hope that answered your question, Aditya. So I had the next question, which is how expensive it is. So um, obviously, multi-fold less expensive than the status quo solutions out there. And this is as with any electronics. This is this is goes down with volume. So today's technology, the standard market rate is $4 to $5 a day for track and trace solutions. We can bring it down to, you know, like tens of cents. Or again, if Intel doesn't make product, Intel sells ingredients and technology. So my go-to-market partner should be the one who is quoting the prices. But again, we can drop the current market rate by, I know, by 4 or 5 times low, right? So just through technology, through IoT and architecture. Um, we have this next question from KG. Are you seeing any good technology in very small, low cost postage stamp size or smaller low cost asset tracks? Not yet. So there's a lot of hype, and in fact, I was talking to a company today morning, doing some nanotechnology, enabling some nanotechnology for this purpose. So we will get there, especially energy harvesting and no batteryless systems, and we'll get there, but not today. I would say it's at least a few years away before we'll start seeing something that we can call a product, right? That people can pay for. RFID still seems to be the dominant force in low-end tracking, like 10 cents, 5 cents range. But obviously, RFID has its own limitations, right? And it cannot give you more than location, not necessarily at that rate, cannot give you condition. And also RFID instantiations a mobile instantiation of RFID has its own issues, so which this technology overcomes, right? Then I have another question. Yeah, it's the same question. Active asset track versus passive. Absolutely. So active is RFID, passive RFID active technology hasn't matured enough to be able to meet the passive technology rates yet, which is like sub 10 cents. And I believe we'll get there at some point, both due to volume as well as the new technology disruptions happening, right? So there could be a future where you have literal end-to-end tracking, which is every part right from the manufacturing plant gets put on with a tag and or tag like thing, and then you can track it all the way to the consumer. So all the way to insights from how the consumer is using it and things like that. So that'll revolutionize the way supply chain works, and that's going back to the picture you have on the slide here, which is truly autonomous supply chain, right? So that technologies like that will be key to enable that. So I have another interesting question. Somebody asked me, how about 5G support? So, uh, so 5G, I believe in 5G, right? That's going to change the world, and Intel is in the middle of it, which is great. Um, so we really have a problem with the cellular technology today. So trying to enable global connectivity is not easy, especially in LTE domain, right? So different bands, different licensing, and it's not seamless. So for localized technology is great, right? You can have, you can exploit the low data rates or low power technologies, but making this work in low global is a challenge. And unfortunately, shipping is global, right? If you and global and multimodal, 70% of the pharma travels on air, at least at one segment on air, right? And then there's ships, without connectivity in the middle of the ocean. You don't have 3G or 4G. I see 5G as a solution for all that. A global connectivity, multimodal connectivity, all the way from low data rate, low power to high data rate, high power. So I'm looking forward to it. I'm looking forward to 5G, but at this point, 5G is not there yet in terms of onboarding. So I can absolutely see a skew coming out in the roadmap with 5G support, and I hope 5G would solve some of the issues you're running into today in terms of global support. By the way, this technology that we have, first instantiation is 3G, and we went specifically with 3G so that it can work global. So we have no restrictions, and with 3G with 2G fallback, right? So we're sure we can hit majority of the countries with this. So then this is and my customers are need global, so shipping is global. So we had to go with that, but we would love to leapfrog to 5G as soon as it is ready. Another question here: will it work with satellites? So satellites are relevant, especially in ocean, and ocean is definitely a big segment for us. So the way we are approaching it is we didn't want to do multiple SKUs, right? One satellite and one cellular SKU, or so respecting the fact that cost is everything. Trying to minimize cost is goal number one. The approach you're taking is you can connect this gateway to a satellite, external satellite comms box. So most of the ships have satellites comm boxes that will accept input either through USB or Wi-Fi. Uh, these gateways can do both, right? So if you have gateways connected to your satellite box and ships, you can have now these tags distributed across the ship in a massive network talking to this gateway. Gateway aggregates the data and sends the satellite box, and that way you can communicate. So this gateway instantiation that you see today in itself does not have satellite. I have another question, which is what are in this network? So I believe the person is asking about cellular connectivity partners. So the gateway is certified on PTCRB and GCF and on AT&T network. So it can do worldwide connectivity through that, right? Either you can do AT&T global SIM or you can do an MVNO SIM. With the industrial and GCF, it should have no problem connecting to the network. It's legally safe to connect to the network. And then we're also looking at countries and trying to onboard countrywide carrier certification, like Docomo or Vodafone. And so these things takes time, but we decided to go with AT&T initially, and then fall back on PTCRB and GCF. Size and weight of sensors. That's the next question I have. So size is about, again, the first SKU is a global superset SKU, which have all the sensors. So for example, to track shock and vibe, you don't need a temperature sensor. So I can see this multiple SKUs coming out through partners soon. Today, the size is the sensors is less than the length of a credit card, about the width of a credit card, and I would say about 5 credit cards stacked up in terms of width, height, and in terms of weight, I think it's around 12 ounces, if I believe. I have to go back and check the numbers, but low weights, and we have this nice way of you peel and stick. So you have a strip coming out that you can pull to activate the sensors, and then you can have either do peel and stick on cardboard, or if it doesn't stick, you can have a sleeve that you can staple in, or tie to your package. And to add to that, gateway is a size less than the size of an iPhone 6s Plus that can sit anywhere within 100 meters, right, within the truck, and travel with the package. If you go to Intel's website or Honeywell's website, you could learn more about this solution. You'll have descriptions and product specs and all that good stuff. I have a question here that says Amazon can use that on their drones. Absolutely, I don't see why not. Drones are exciting technology, and we didn't have time to talk about that today, but Intel is doing a lot of work there as well. So with drones, I mean, thank you all. Thank you for listening in. Thank you for the questions, and hopefully this was helpful. Good luck with the other sessions as well. Bye.